Good afternoon, folks. This is my second video on electronic circuits. You can see before me a couple of breadboards. This was the breadboard that I built for my first video, and basically it comprised two LED lights, a power module, and a NAND circuit, NAND gate, NAND chip actually, with where two NANDs were being used and two push buttons. And if I powered it like this, you would see one of the NANDs would open, and if I toggle the other switch, it would toggle back and forth on the commands, right? Now the purpose of that video was basically to show how memory can store one bit of information by using two crisscrossed NAND gates, and it made use of the 74LS00 NAND chip that you see right here where I'm pointing at. These other two chips, the timer and the counter, were not used for this particular circuit, and the idea was to visually demonstrate how memory, an SR latch, a set reset latch, can be used to store one bit. So it's basically a basic memory circuit, right? And you could do similar things for 2-bit, 4 bits, and do more fancier stuff using half adders and adders and whatnot, and build maybe, let's say, a 4-bit computer CPU down the road. So that was for my first video, and you can also see, if you recall, I had mentioned that these two 47 kilo ohm resistors were to protect the NAND chip, but that was not quite correct. They're actually pull-up resistors. In transistor logic circuits, of which the NAND gate is one, they operate by sensing voltages, right? So low would be 0 volts, high would be 5 volts, and therefore when these two buttons are not pressed, basically from the power rail, these two resistors pull up the voltage to be high, which would be read as 5 volts, for example, and that would be encoded as 1, for our purposes. So it wasn't to protect the NAND gate, so that's a correction I wanted to point out. The second breadboard you see here has got a passive magnetic buzzer. So it's not a piezo buzzer, it's just a passive magnetic buzzer that can be used to generate tones. And why do I have it on here? So basically what I wanted to do was introduce you guys to the Arduino Uno. And you can see that this is basically powered by I don't know if you'll be able to see this, but by the ATmag 328 AVR chip, and it's basically a microcontroller that can interface with servo motors, with buzzers like this, with different sensors, to do really cool, nifty electronic projects. And how it works is basically you would be downloading programs or firmware onto the ATmeg chip using stuff that you write in the Arduino IDE. So in order to make use of an Arduino Uno, to interface with it and make it do useful things, you would need to download an Arduino IDE on your laptop or your PC. How it interfaces, so basically on the power front, it can be powered through a laptop through the same interface cable, and obviously if you're using it away from your laptop, you could power it with a 9-volt DC, for example, battery. This here is a reset button. Basically resets the program back to initial, and whatever you download here stays here until you download another firmware to replace it, right? And you can see, for example, there is a powered on LED here on the left. There are two transmit and receive LED lights, and there is a LED light here down here that you can make use of. If you don't want to interface with any external breadboard, for example, external device, you can play around with that LED there. So actually, once you interface it with a circuit that's connecting the buzzer, you could generate musical notes, for example, right? So what we are going to do for this video, if you recall, I had mentioned in my first video that nowadays you can vibe code, right, your way to workable applications on the software front, and you could do the same thing with hardware. So you don't really need to take the slow approach of learning all the fundamentals first if you don't want to, though I believe that's a sounder strategy in the long run, especially if you want to do very sophisticated things some months or years down the road, depending on how committed and disciplined you are in learning. But I was thinking that what could you do right away, even with minimal training, and obviously you would be making use of ChatGPT and Claude to write such programs. So what I'm going to do is I'm going to connect this printer cable to the interface here, and you hear a beep, and the other end is basically connected to my Lenovo laptop. Now in my case, I like to play with terminals, so like PowerShell and Windows Subsystem Linux. So basically I had ChatGPT explain how could I install the Arduino command line interface onto Ubuntu on the Lenovo laptop in the WSL environment, and it did that for me, and you can see, for example, it's running here. Okay, please excuse the sunny glare. And what we need to do first is, because I had pulled out the cable, we need, using PowerShell, to reattach the Ubuntu environment with the board. So there's a kind of a command line called USB IPD attach that you can see that down there, and once I press enter, it should ping again after it connects. Okay, and how do I know that it's connected? Well, you could tell ChatGPT to give you a command line on now that you can use in the Ubuntu section. It's basically called Arduino CLI board list, and I click that, and it should now show the board list. So you can see, for example, it says Arduino Uno connected, right? So that is basically what I mean by the basic interface, and you can see now even the power on LED light is on. Now normally when you do your first program, when you power the Uno, some have a default blinker circuit that starts flashing this light automatically. Other people would have like a hello world equivalent that you can basically upload a program that flashes this light. And we're going to do a similar hello world project but with a slight twist. So this is where I make use of my friendly ChatGPT, and I basically gave it a prompt saying that I wanted it to do different things if you press different keys on the dashboard, and as you can see, it actually wrote a program, okay, in C++. Please excuse the glare again. And what you do is you open your WSL terminal and you use the Nano editor to write a program, and once you write a program, the Nano editor looks something like this. Let me just, so that's basically a nano editor, right? It's a GNU Nano editor, and you would be able to copy paste whatever you have there and then save it. In this case, there's already a file called blinkled.ino. After you do that, you basically then do a few things. So for example, you can compile it. Okay, so you would write your compile instructions, but you need to make sure that the INO file is in its separate directory, otherwise it won't compile the sketch. Once you compile it, then what's going to happen, it's going to tell you something like, 9% of the program storage space has been used, and that's basically saying that okay, the compile is a success. And after that is when you use an upload command line to move it. So you can see I wrote another command line called upload there, and you basically move it to this chip here. Right, and if I press that enter, you should see the RxTX buttons flicker. Okay, that's because data is being exchanged from the laptop onto the chip. Okay, once you do that, because I had instructions that there should be a command based program. That means I type a key on the laptop and it does something. Then what you need to do is you also need to have some sort of a monitor command line that basically opens up a menu on your laptop where you can then key in those commands. So you can see, for example, I now have a menu of like a LED controller with an O for switching on the LED, X for switching it off, F for blinking fast, S for slower blink, N for normal blink, H for heartbeat, and if I want a question mark. Right, so you can see it's waiting for my response there. So let's first of all switch on the LED light right on the lower right, and I'll say O and I press enter, and you can see that light has switched on there. I hope you can see it. Okay, and I'll say O again for off. Actually it's X for off, and then O for on, X for off. Okay, after that I'll just say N for normal blink, and you can see it will blinking normally. Okay, I can slow it down. If I say S, I can slow it down further. You can see it's kind of slowing down. Okay, and if I want to build it faster, blink it faster, I'll say F, 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 F. Say F again. Say F again. Say F again. Say F again. Faster and faster. Faster and faster. One more faster button. Wow, you can see it like really blink fast, and that's basically, you can see every time I was pressing F, the blink delay would go from 550 milliseconds down to 50 milliseconds. So that's really fast. So I wonder what would happen if I say one more F. It's basically actually won't go faster than that. That's like 50 milliseconds fast. And if I say normal blink again, N, or let's say go back, I say S, you see I can slow it down. See, so you can see the transmit button flash sometimes. So right, it's receiving a command. You can see it flash, RX flashing, so it's receiving a slow down command. Okay, and then you can speed it up again. Okay, or I could make it go normal again. Let's try normal. Okay, doesn't seem to work. Probably it's caught in a loop of some sort. I'll just slow it down first. Okay, and that's how it works. So thank you folks, and you can see if I say H, it beats like a heartbeat, and that's how it works. And I switch it off, X off, and the LED is off. So thank you guys for joining me. I appreciate the time, and happy learning.